All right, let's go ahead and jump to chapter 11 here. We're going to do pre-algebra today, lesson 11-1. I would say that we've been working all year up to this. And the reason I say that is that PA lesson 11-1 starts us into this lesson on functions, looking at equations, how they work, okay? And so part of what we have to understand about this is this idea of again, bringing it back out, the function machine, okay? The function machine. So if you recall, we've already done this once this year.
Mr. Bournemouth, where's James' test? Did he take those tests?
No, not yet.
I just didn't know. I didn't have it. H-I-J. Okay. My test for James' test. Oh my gosh, James. Did you really just ask that question? What did he say? He's not even in this class.
Did you turn in your reteach sheet? Oh, okay, then that's why. All right, this is the function machine.
No, it's not. Too complicated.
Thank you.
Wait, but the two buildings aren't like connected.
No, well they are through a tiny little corner.
There's a little tube in the back. You just can't see it. Yeah, probably.
Okay, so yeah. So here's what we have going on. We have, and I'm not exactly sure why that disappeared up there. But basically what we have going on is we have this thing, the function machine. And what is the function machine's whole purpose? We have a what and a what? Anybody remember? An input. Okay, so we put something into the factory. And then we have also an output. It is. It is.
No, Bo, seriously, what page are we on? 512. Thank you. 513. 514. No, we're on 512.
We're on 513.
Colby, I found the page already. 512 and 513 are on.
See if that helps. All right. So we have an input and an output. So let's look at an input-output scenario here. An input-output scenario. We're going to look at two of them. Input and output. Does anyone else know what we call input and output? What else do we call them? Yeah, Colby? Come on, say it louder. I heard someone say X and Y. You input X, you get out Y. Okay? You input X, you get out Y. You input, output. Now, before I fill these charts with numbers, I want to look at one example of an input-output scenario.
Didn't the Math 7 kids just take a quiz on this?
They did. They did. So, yeah, this should be fairly, this should be review for you. It should be similar, or you should recognize it. Y equals 2x plus 3. Where's my input? Gloria? We can make it even simpler than that. It's right here. X. Yep. And so if I put something in for X, what am I going to get out?
Y.
I'm going to get out Y. Okay? So I'm actually going to draw it as like a down arrow. Like I put into X, I get out Y. Okay? Can I put anything in for X? I really can. Absolutely I can. Okay? I could put in 0. What would be my output? 3. Very good. And at this point, you should know this, right? If I put a 0 in here, anything times 0 is 0. I add 3, I get 3. If I put a 1 in, what is my output? 5. If I put a 2 in, my output is?
7.
Oh. 2 times 2 is 4 plus 3 is 7. If I put a 10 in, what do I get? 23. So you're familiar with the input-output idea here. Okay? Input, output. Okay? It seems somewhat simple, right?
Yeah, but it's gonna get harder.
Well, it's not going to necessarily get harder.
There's no graph. It's gonna get longer.
Well, eventually you'll have to graph this, yes. But it's not hard. Shh, guys. Really?
Yeah.
No. No. Okay? So this is a function. This is like the function machine. I have an input. I have an output. Part of what I want to do today is I want to look at a series of numbers, okay, a set of numbers, and look at what's happening. Okay, so let's just use this as our model. 2x plus 3. Let's go back to this one here. Wow, this is being very glitchy today. All right, so I'm just going to write that function above here, 2x plus 3. Okay, if I input 0, I get out what? 3. If I input 1, I get out 5. If I input a 2, I get out a 7. If I input a what? 3, I get out a 10. Is that right?
No.
9. Okay. So what's happening as we go down this column? It's what's happening? It's increasing by 2.
Or it's odd numbers.
Okay, that's another option. So this is going increasing by 2 each time. It's increasing by 2. I'm not sure why it's so laggy, by the way, but it is, I guess. So if we're looking at this and we're saying, okay, it's increasing by 2, where in our function is a 2? There's a 2 in front of the x. I want you to kind of hold on to that relationship for just a moment. Now, and the next thing I want you to look at is how do I get from 0 to 3? I had to add 3. Where is there a 3 in my function?
Oh, it keeps increasing.
Now, I will tell you this. The unique relationship of an input of 0 and the output is very important. It actually helps us to figure out the equation. All right? So I'm going to show you how this works. I'm going to kind of give you the hint or the behind-the-scenes look at this. So I'm going to come up with a random set of numbers here, and I want to see if you can figure out the equation. All right? My input is going to be 0, 1, 2, 3, and 5. Okay? Waiting for it. There it is. Okay? And my output is going to be 6, 18, 30, 42, and hang on one second. Wow, this is taking a long time. It's not going to be 50, sorry. It's going to be 66. Okay. So here's what we have to decide. Okay? There is a actual kind of like a recipe for figuring out functions. Okay? There's a recipe. So looking at x, looking at y, you look and say, okay, these are my inputs, these are my outputs. How much is my output going up each time? How much is my output going up each time? That's the first thing we look at. Kind of like the plus 2s on the left-hand side here. Yeah. It's going up by 12 each time.
But the last one doesn't go up by 12. It's because there's no 4. It's a 5. It goes from 3 to 5.
Oh.
Shouldn't there plus 2? 0 plus 2.
Oh, you're right. I wrote it again, obviously.
Just put a 1 in.
And I'm actually drawing arcs that I didn't, obviously, not sure why. There it is. There's another one. Wow. I didn't even remember I drew that. Okay. So I've got plus 12, plus 12, plus 12, plus 12. And then what about the relationship between 0 and 6 here? Okay, it's going up by 6. So I'm going to make that green. And I'm going to say plus 6. Okay, if we were using this as a model on the left-hand side, the 2, the 3, the 2x plus 3, what could we kind of hypothesize that the function would be for this right-hand table? Mary? Y equals 12x plus 6. Okay, we take the difference in the y column, we put it in front of the x. Sometimes that's negative if it's going down. In this case, it's positive because it's going up. Okay? And then we take the difference only for 0. Not 1, not 2, not 3, not 5. But what's it take us to get from 0 to y? It takes plus 6. That's important. It has to be the 0 point. So try it. Plug in 5 and see if you can get out 66. Plug in 5 and see if you get out 66. 5 times 12 is 60 plus 6, 66. How do I know it's not 6x plus 12? Because it won't work for any of the points. I mean, try it. 6x plus 12. 6 times 5 would be 30, plus 12 would be 42. 5 does not have an output of 42, so it wouldn't work. Okay? And if you plugged a 3 into that 6x plus 12, it would be 6 times 3 is 18, plus 12 would be 30. So actually what it is it's 1 short each time. Yeah.
So usually you're going to do x times the number, the output goes up
plus whatever it takes to go from the 0 point to the output column. And that always works every time. You can put one in. That's the benefit. If you know how the y column changes, you can work it backwards to 0.
Yeah, Colby.
Sorry, Emma.
That's a great question. Yeah, Reagan.
Okay, you went plus 12 between 42 and 66, but you didn't have a 4.
Oh, you're right. It's actually plus 24.
That still works.
He doesn't even remember writing that.
Yeah, I don't know. The computer's kind of got a mind of its own today. While it erases, I'll grab another pen here. It is plus 24 because I jumped from 3 to 5. So I had to jump 2 spots. Okay? I could have. I didn't want to on purpose. And if you were doing this on your homework, though, you'd always want to try test points of like 0, 1, 2, 3, or -1, 0, 1, etc. I'm showing you right now where we're going with this. Okay? Your homework is not going to be nearly this hard. Actually, your homework, this is going to be the culmination of the next several units. Okay? The next several lessons. The reason I showed it to you is I figured you could handle it today. But the one thing we're doing today, we're focusing on finding patterns in the output column. That's what we're focusing on. So
basically, you learned the whole section.
Well, you learned a lot of it. Yeah. Okay?
What's a geometric sequence?
That's what we're going to today. All right. Let's take a look at the following, what's called sequence. Grace? Grace, a sequence is a series of numbers, one after another. So, Grace, you are what, 6 years old? So you've sequenced 1, 2, 3, 4, 5, 6 years, going up by ones. Okay? So let's look at a sequence of numbers. Let's make the numbers look like, let's go with 100, 50, 25, 12.5. Okay. Now, patterns are meant to be there for you to see them. Is this going up or down by a regular amount? Okay? So the first thing you would do if you're looking at a sequence is you try to see if you can add or subtract between the same amount between numbers. So to go from 100 to 50, I have to subtract 50. Okay? Does that work here?
No.
It doesn't. If you can't add or subtract, you have to switch over to multiplication or a division. Okay, so I heard times -2. Okay. Times -2 would be -200. No. Oh.
Or we could just say divided by 2, please.
No, actually, I like the times 1/2 better. Shh. Okay, not sure. It's wigging out over there, but basically, if you multiply by 1/2 or divide by 2, that's what's happening here. If you have to, ladies and gentlemen, and this is where your homework is. If you have to figure out a pattern, and in order to find the pattern, you figure out that you have to multiply or divide between each term. This is called a term. A term is one number in a sequence.
I don't even remember when you wrote that.
It's his friend Casper.
Okay? So terms. These are terms. Emma. Okay? They're terms. They're one number in a sequence. If from one term to the next term to the next term, you're multiplying or dividing, then you have what's called a geometric sequence.
So it's only geometric when you multiply or divide.
That's exactly right. Right. So this is a geometric sequence because I had to multiply by 1/2 or divide by 2. What you should also understand is if you can multiply, you can divide. You can actually do both. If I can multiply by 1/3, I can divide by 3. Okay?
It's usually easier to do the dividing by a whole number.
No, just a different way of representing it. In theory, you could say that there is no division. It's all just multiplying by a fraction or a decimal. It's both. If you multiply or divide, because in essence, they're the same thing. If I multiply by 1/2, that's the same thing as dividing by 2. It's just how you look at it.
If I divide by a fraction, then I'm multiplying.
Exactly.
Just make 1, not 2.
That made sense if we could do it that way.
Fractions once, not twice.
All right. Next one. Is it? Now, do I have to multiply or divide here?
Well, you could divide.
You can multiply by 1.68.
What am I doing each time? Yeah.
You're adding 2.
I'm adding 2. Plus 2, plus 2, plus 2. No, this is not going to be right. Yeah, no. Plus 2, plus 2, plus 2. Okay, when you add or subtract, okay, which subtraction is just adding the opposite, so really they're both addition.
You could add -2.
That's no.
Subtract. No.
You would subtract a negative here to get an addition of 2.
What? Subtract the -2 instead of -4. That's what I said.
You can subtract both.
Or you could add -2 then. Wait, how do you add negative? How do you add a negative?
No.
All right, pause. 5, 4, 3. All right, I'm going to let you think on that for a little bit, but nonetheless, they're adding here. This is called an arithmetic sequence, okay? Or you could, some people say arithmetic, but arithmetic sequence, okay? Arithmetic. And actually, you can find this in your book on page 513. Arithmetic.
It looks like it has 2 R's in it.
Well, that's an I. And that's not an E, that's a C. An arithmetic sequence. So if you are adding or subtracting, it's arithmetic. If you are multiplying or dividing, it's geometric. I'm going to tell you this, though. Sometimes it's both. I'm going to show you. I'm going to show you another one. There is another way to write these, okay, where you can say you have input and output. Okay, so let's say that we have what's called n. N is a common way that we express the term number. The first term in a sequence, the second term in a sequence, the third term in a sequence. I'll give you an example of what I mean. This is, I think it's just Smart Notebook today. All right, first term in a sequence, 2. Second term in the sequence, 4. Third number in the sequence, 6. Fourth term in the sequence, 8. Fifth term in the sequence, 10. Sixth term, 12. Seventh term, 14. It's the number in the sequence. Okay? That's n. So n always starts listing them by 1, 2, 3, 4, 5. So we're just going to do 1, 2, 3, 4, 5. N just means number in sequence.
Also, it could be N1, N2, N3.
So I'll give you an example of what this would look like in high school. In high school, they might ask for what is the number in the sequence when n equals 100. So what you would have to do is you would either write the sequence out to the 100th term, or you'd figure out a way to get there mathematically.
I'd write it out.
Okay? So if I were to ask you, based on that kind of question, let's go back. Let's go back here. What is the term when n equals 3? What would you say? 25. When I say what is the term when n equals 3, you would go first term, second term, third term, 25.
How would you figure that out?
You count.
No, without writing it out.
You can't. Not yet. Right now, I'm just asking you to kind of tie these ideas together. These are called terms, and I'm going to have you identify where they're at. Yeah.
So, it'll be a problem where has you do that, and then it has to say, then find the third term.
Exactly. If this was on your homework, it might ask you to say, find the 5th term, or when n equals 5. So you'd have to go through this, and then you'd have to get to here, and you'd have to take it one more step.
Do they always say it's N?
Yeah, no, they will. If you look in your book, they call it position, and it's there in just about it's in there in all the tables. So in the example problems, n equals the 20th term. Okay, n. This is a very, very common way of saying this. Mary.
I don't get why you have the N there because, why do you just say find the 20th term?
Because it's not, and here's why. N is the same thing as input. So sometimes we'll manipulate n. So I might say, I want you to do this. I want you to take the term, and I want you to go take 3 times the term and add 2.
So 3 times which term?
Now it becomes an input-output situation. See what I mean?
Wait, but I thought the term was already an input-output. I got it now.
These go up by 1. 1, 2, 3, 4, 5, 6, 7. Go back to look at these tables.
Which term are we using, though?
0, 1, 2, 3. 0, 1, 2, 3, 5. X is the same thing as n. Input's the same thing as n. The reason I have to show it to you is that your teachers, and as algebra unfolds, you have to understand this idea of the nth term. The nth term is a very important idea. So,
Use the output column. Because before you had the 150, that was the output column.
you're right. I didn't give you the input column. This, if I did have an input column, it would be 1, 2, 3, 4. And on this one, it would be 1, 2, 3, 4, 5, 6, 7.
So it would be n, like 2 would be n1.
I mean, I can put it in there. I think we're overkilling it, but basically, every sequence has an n series. 1, 2, 3, 4, 5, 6, 7. This is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term. Okay? Let's go back.
I got it.
This is the first term, second term, third term, fourth term. Wait for it.
So sorry.
There it is.
There's something hiding in this one.
This is an arithmetic sequence. This is the first term, second term, third term. This is the zero term. There is one. This is the arithmetic sequence. It's going up by 12s. This is the zero term, first term, second term, third term, fifth term.
How can you have a zeroth term?
How would that be?
Because mathematically we can't.
How would that
You can figure it out here. What would the zero term be? Zero.
Mr. Bornhammer, how would that be an arithmetic sequence if there's multiplication in it too?
It's arithmetic because you're looking at just that column of numbers, and it's going up by a set amount.
Okay. So it will tell you what n is, and then when you have to plug in the n, it's 3n.
Let's do this. This is a sequence that is both geometric and arithmetic. Okay, because we're multiplying and adding. There are problems that are going to ask you how to identify both. So let's do this. 1 times 3 plus 2. What is it?
5.
The first term is 5. What is the second term?
2 plus 3 plus 2. 6, 8.
Now, stop there. What's in front of the n?
A 3.
A 3. We know this is going to go up by 3s. So can you find the next one without doing this? 8 plus 3 is 11. 11 plus 3 is 14 plus 3 is 17 plus 3 is, and then you keep going.
Wait, so would n just basically be y? Be like y?
But Grace, the reason we use n is even in next year when you guys are in algebra, you're going to be asked to find the 100th term. So they're going to say when n equals 100, find it. Well, you're going to use something like this. When n equals 100, we can find that even here. It's going to be 302. Because I just plugged 100 in for n. 3 times 100 is 300 plus 2 is 302. If n equaled 1,000, they wanted you to find the 1,000th term. 3002. See, you can find a number way in the distance using this idea. So it becomes more than an input-output XY situation. Colby. Sometimes they'll have you do it both ways. Sometimes they'll give you the sequence and they want you just to say what's it going up by. Sometimes they'll ask you, is it arithmetic or is it geometric or both or neither, which I don't think there is a situation like that. Sometimes they'll ask you to identify the nth term. Sometimes they will ask you to write the function for the sequence. Okay, so they're going to ask you all of those things. If they want you to find the 100th term, they might give you just the first set of numbers. You'd have to write the equation, plug in 100, and give them the answer. But see, I don't think that's as hard as you think it is. Because you know that when you look at the difference between the numbers, you look at the zero term, you can write the equation pretty easily, plug in the number you need, get an output. Mary. Right. You're right. Horizontally as well. Yep, so Mr. Bornheimer's bad. He rotated it. No, it's okay. That's a great point that you make. We have input, output. Instead of going up and down, it's going sideways. Yep, you'll see both. That's a good thing that you brought up. All right, if you look ahead at your assignment for the evening, and I'll give you that in just 1 second, you'll see that they'll ask you to write the next 3 terms in a sequence. They're going to ask you to identify the first 4 terms of an expression, which is an output scenario, like 3n plus 2. they're going to ask you to describe the geometric sequence. So how much is it being multiplied or divided by? They're going to ask you to identify additional shapes in a sequence. I mean, all of these things are what we did today. Caleb.
Okay, so in the equation, there's 3n plus.
Mm-hmm.
So by n, like, do you mean the third n, which would be 11?
Right. So let's say if I asked you, what is n equals 7? What would you say?
It would be 23.
You're right. You answered that perfectly. In a problem, they're going to give you a list of numbers, and they're going to say, find the next 3 terms. That's your first couple of problems in your homework tonight. So you'd say 23, 26, and 29, done. Boom. Because you found the pattern. You didn't even have to plug in here. Yeah.
So it says like the common difference. So the common difference on that would be 35 maybe.
You're right.
Okay.
Yeah.
What's the common ratio?
Common ratio would be like multiplying by a half each time.
What's the difference between a common?
Colby.
A difference implies subtraction and addition. A ratio implies multiplication and division. One is arithmetic, one's geometric.
You just gave an answer to his homework.
Hmm.
Cheater.
Hmm.
Well, that was actually
All right. Now, lies.